See, this is a stream, okay? This is a stream. Stream is nothing but a water body, something like where the water is flowing, okay? So water flows through a river. So river is also a stream, correct? And you know, like a boat can row on a stream. That means a boat can row on a river. So this chapter is all about the speed of the, find out the speed of the boat and speed of the stream. Okay. And in some cases, that means you assume this is some small river. It's a stream, some small river. So it, suppose it is coming from some mountain. Okay. So this is a mountain from where this river is coming. This is going towards the Bay of Bengal, for example. You're not studying any science, geography, just to understand. So from here, if it is flowing, it is down, it is called downstream. That is from mountain, it is moving towards Bay of Bengal, downstream. If it is moving from Bay of Bengal towards mountain, it's called upstream. Okay. And if the boat is rowing this direction, it is rowing downstream. If the boat is rowing this direction, it is rowing upstream. Okay. Now, see, all of you may be knowing, you know, Tirupati, when you go to Tirupati, some pilgrimage places and some mountainous region. So you see, when you are like, when you are traveling upwards, lot of efforts have to be put. Okay, that means it is not only, if you suppose you have taken a cycle and you are just going upwards, and you want to reach some point on the peak, so you need to cycle, and you need to cycle upwards, correct? And you have to put a lot of efforts. In that case, the efforts would be very much, correct? But if I say that if you are moving from the top of the peak to downwards, the efforts put by you would be very less, correct? Because if you just pedal somewhat, since the since it is downwards, and if you pedal just somewhat, the road itself is in is such a way, the road itself is in such a way that you need not put much of the efforts, and you would be going down very easily, correct? So much, if you go upwards, you have to put more efforts. If you are coming downwards, less efforts, very easily you can come. Okay, so this thing you should understand. In the same way, if you are rowing downstream, less efforts. That means your speed and since the movement of the stream is also downwards, so the speed with which you are moving, your speed of the boat, and here the speed would increase because the stream is also moving downwards. In case of road, you need to pedal, but in case of river, the river will also flow with some speed. So if the river also flows with some speed, that speed would be added up to your speed. Okay, and the effort becomes very, very less. Okay, so it's a very common sense thing. So if I am slow, if I am just going downstream, if I am rowing my boat downstream, my efforts would be less. Why? Because my speed of the boat would add up with the speed of the stream, speed of the river, because it is flowing downwards. It itself, if you don't even row, it itself will take you downwards because it will move. It is moving. You know, the water of the river is not stagnant water, it moves. Okay, so here speed of the boat plus speed of the stream is the concept, if it is downstream. Now it is in the opposite direction, for example, going upstream, you need to row against the stream. and here it is not added up. You have to beat the stream's speed. That means you have to go in opposite direction, and here the efforts would be very much. So speed of the stream boat minus speed of the stream. This is in the upward case, opposite direction, correct? So these are the concepts. Now based upon these concepts, let us derive some formulas. Okay, and these are the formulas which you need to put for every question. Okay, now, so all of you just make a note of this. I'm just writing the formulas down. Okay, now see. So if the boat, suppose some assumptions I'm making here, if the boat is moving at speed of x kilometer per hour, this is the speed of the boat, and the speed of the stream is y kilometers per hour, then speed downstream, that means the boat is moving downstream and it is going along with the speed of the stream. So I said when they are moving in the same direction, add. If the stream is going downwards and this is boat is rowing downwards, they are going in the same direction, add. But if the stream is going downwards, and because stream will definitely flow downwards, it won't go upwards, that never happens. And if you are rowing in the opposite direction, negative sign. These two logics you need to understand, and things become very easy for you. So speed downstream, okay, here I'll write boat moving along the stream. So I would write here VD, speed downstream, is equal to speed of the boat plus speed of the stream. All of you make a note of this. Yeah. Now, in this case, this was the first one. Now second one, speed upstream. Boat moving against the stream. So boat is moving against the stream. speed upstream is equal to x minus y kilometers per hour. All of you make a note of this. Okay. Now, after this formula, this is the next formula. If speed downstream and speed upstream are known, then speed of boat in still water is equal to half Vd plus Vu. This you have found out. This you have found out. And this is the speed of the boat in still water. This is the formula for speed of the stream. Half Vd minus Vu. Just all of you make a note of this. Still water means the boat is not moving. It is just at one place. Okay. And already you know this, the formula, speeds formula is distance by time. So distance is what distance here? Downstream distance by downtime. And this is distance by time again, upstream distance by uptime. And here half downstream rate, that is speed plus upstream rate, and here half downstream rate minus upstream rate. Rate means speed. All of you make a note of all this. Okay, now let's do some more formulas and then jump to the questions. See, sometimes you may be getting some case whereby when downstream distance is equal to upstream distance is equal to d. So that means downstream distance is also suppose some 100, some 50 kilometers, upstream distance also 50 kilometers. For example, let's say. So in that case, man's rate in still water whole divided by speed of stream is equal to x is equal to is equal to downtime plus uptime, that means total time divided by uptime minus downtime. See, this is when I'll be explaining you one question, I'll be showing this kind of this formula when it is applicable. Okay, now you please make a note of this. And the next formula, when downstream distance is equal to upstream distance is equal to d, say then average speed for total journey, that is up and down, is equal to so I'm just writing the formula here. Total distance, that is going up and down, that means if it is up 100 meters, down 100 meters, so it will be 200, that means 2 into d, because d is 100, so 2 times of 100 would be 200. Okay, so total distance 2d divided by total time is equal to upstream rate, that is upstream speed into downstream rate whole divided by man's rate in still water. All of you make a note of this. We will now do the questions and apply all this so-called formulas. Come on, right. Okay, now let's do the questions. I'm giving the question number 1 and I expect answer from all of you. Very simple questions. Direct formula substitution. A man can swim downstream at 8 kilometers per hour and upstream at 2 kilometers per hour. Find man's rate in still water and the speed of current. Come on, do this. All of you. Yes, what happened? Yes, I am expecting the answer. What is this? I don't understand why you are not all participative. When it comes to maths, you're all mum.
Doing,
Don't give
sir.
any answers. Tell
Doing,
me the
sir.
answer. Yes, yes, please. Appreciated. Your efforts are appreciated. We want that. Do it, do it. So they're asking you, okay, let's do the first one. I will do the first one for you. They're asking man's rate in still water. What is the formula I gave you for man's rate in still water? I clearly told you half downstream rate plus upstream rate. That is, what is your downstream rate? If you can tell me VD, upstream rate VU. I gave you na half VD plus VU still water, correct?
Yes, sir.
Now, what is your downstream rate? 8 kilometers per hour. What is your upstream rate? 2 kilometers per hour. Just take this. That's it, finished. 5 kilometers per hour. Direct formula substitution. Then speed of the current or stream, anything is all right. Half Vd minus Vu. So half, what is Vd? 8 minus Vu was T. So 6 by 2 is 3 kilometers per hour. All of you make a note of this. We'll go for the next question. Okay, let's do the next question. Please solve this. Come on, do this question. And in fact, I am giving you the formula also how to do this. Speed of current, what is the formula for speed of current? Half Vd minus Vu. Come on, now you need to solve this. Excuse me, just solve this.
Sir, answer is 1 kilometer per hour. Sir,
Yes, sir. 1 kilometer.
1 kilometer, sir.
Yeah, so what is the answer?
I got 1 kilometer, sir.
Me too, sir.
Just a second. See, this question, the data is not given directly to you. Here they have
21
given
kilometer.
distance
Divide
and
by
they have
5,
given
divide by
time.
5.
So you need to find speed, correct? So distance by time, and again, sorry, this is upstream. Okay, downstream is 30.
But 4, 2.
Okay, now next question. Simple, na? Next question. My God. 2 minutes. It got stuck. Come on, do this. And also try this question. Okay, solve these two questions.
Sir, rate of current is 1 kilometer per hour.
What?
For first one, answer is 1 kilometer per hour, sir.
Yeah, rate of current is 1 kilometer per hour. Yes.
Yes, sir. And sir, rate of rowing is 7 kilometers per hour, sir.
Yes.
Okay, sir.
Correct. Okay. Let me solve this too. See, what did they ask you? Find the rate of rowing in still water and the speed of the current. As you know very well, the speed of the current is half Vd minus Vu, correct? And like boat, speed of boat in still water is equal to half Vd plus Vu. Very simple. Just we need to put the things here. They have given the things in minute. They have given a boatman can row 2 kilometers against the stream in 20 minutes. Correct? So they gave it in minutes. We can also do it in kilometers per hour. There's no problem. So let us put this kilometer per minute. So distance by time is nothing but speed. So like a boatman can row 2 kilometers against the stream in 20 minutes and return in 15 minutes. So here distance 2 kilometers and downstream it is like how much a boatman can row against the stream. So I can say this is upstream, correct? And return in 15 minutes. So 2 by 20 downstream, 2 kilometers against the stream. Here the distance is the same. Against the stream is nothing but it's upstream. 2 by return is going upstream and downstream. 2 by 15 minus 2 by 20. Just find out and tell me the answers. half LCM. LCM, you know, 15, you can write 3 into 5, 4 into 5. 5 is over there, 60. So here into 4, here into 3. So here what we can do is into this, like completely 60 into 4 into 3. So 2 by 60. 1 by 2 into 2 by 60. So 1 by 60. This is 60 minutes. So I can say 1 kilometer per hour. That is done. Because it is 60 now. So 60 minutes make it 1 hour. And here LCM is still 60. So 8 plus 6, 14, 1 by 2. So I'm writing here 1 by 2 into 14 by 60. So here the answer is 7 by 60. 60 minutes make an hour. This implies 7 kilometers per hour. Okay. So all of you make a note of this and go for the next question. Come on. Okay, next question.
1 minute, sir.
Yeah, you can solve this.
Sir, 1.3.
Yeah, 1.3. See, a man can row 4 kilometer per hour in still water. Okay. And finds that it takes him twice as long to row up as to row down the river. So it takes him twice as long to see. It takes, for example, if he kind of rows downstream, if it takes him 10 minutes to row upstream, it takes him 20 minutes. Example, because when he is going downstream, he would consume less time. That is understood fact. When he goes up, he would consume more time. That is understood fact. And that to double of this, because the question says us that. Okay. Now, They are asking you find the rate of the stream. That is what is the question. So I have given you a very good formula for this, correct? If you remember, when down, see here, a man can row 4 km/h in still water, and he finds that it takes him twice as long to row up as to row down the river. So they have not given the distance, but as we know, if he is going up and he is again coming down to the same point from where he started, then he is covering the same distance, correct? So can I say in this case upstream distance is equal to downstream distance? Yes. Because from where he started again he has to come back. Okay, and we are taking that as D, for example. So I have given you a formula, man's rate in still water divided by speed of stream is equal to downtime plus uptime divided by uptime minus downtime. This formula I gave you, and now see how I'm going to put the things in this. And here, uptime is equal to 2 times of downtime. Why? Because how much you are taking to go down, how much, if you are taking 10 minutes to go down, you will take 20 minutes to go up. That is double of this. So uptime is 2 times of downtime. Excuse me. Yeah. So now we will put all the things here. A man can row this much km/h in still water. So did they give you the man's rate in still water? Yes, 4 by. Did they give you the speed of the stream? No, you are supposed to find. Downtime is what? Downtime is downtime, but uptime is 2 times of downtime divided by 2 times of downtime minus downtime. So speed of the stream will take there. (1.3 km/h) is equal to speed of the stream. All of you do this. We'll go for next questions. Now next one. Do these two questions. Close the door. Okay, do these two questions fast.
Sir, first one 8 kilometers.
Yeah.
8 kilometers. First one.
First one, 8
8
kilometers.
kilometers.
Yes, good. Okay. So a man can row 6 kilometers in still water. They have given. If the river is running at this much, this is the speed it takes him this much hours to row a place and back. That means he will go and he'll come back, it seems. Okay. So definitely they are asking the distance. And what is given to you in the question? A man can row, they have given the speeds. Distance is equal to what? Please tell me what is the formula for distance? See, distance by time is equal to speed, correct? Correct or wrong?
Yes, sir.
Distance by, no, sorry. Excuse me. Distance by speed is equal to time. Speed is equal to distance by time. Okay. So this formulas we all know, and speed into time is distance. We know this formulas. Fine. There's nothing new. What we are going to do is, they have said that it takes 3 hours to row up and come back. So they are saying 3 hours is the total time, correct? Total time is 3 hours. That means it is taking 3 hours to go up and again come down. This is what they have mentioned, correct? It is the question very simply given. Total time is time upstream plus time downstream. That is 3 hours. Now, how will you find out the time upstream? For time, you need to have distance by speed, and very clearly we don't know the distance, but we know the speeds, and they have asked us to find out the distance. So I'll frame the equation in this way: distance by what is the, a man can row how much? 6 kilometers per hour in still water. So I have, and this is the speed of the stream. This is the speed of the man, speed of the boat in water, correct? So if you remember the first formulas which I gave you, speed downstream and speed upstream, you remember that, correct? You remember speed downstream and speed upstream. So a man can row this much in still water if river is running at this much. So this is the speed of the stream given, correct? So speed of the stream. So total time is what we have is 3 hours. Distance by speed. So we need to find out now. So they have given man can row in still water 6 kilometers per hour. Okay. And we want, see, we want to find out the time upstream. We for finding out the time upstream, it should be distance by speed upstream, correct? Yes, speed upstream. So speed upstream is VU, and then we want to find out the speed downstream, so distance by VD. So speed upstream and speed downstream is given. So speed upstream formula is what, all of you? Can I say x minus y? Please tell me speed upstream is x minus y or not?
Yes, sir.
So what is your
Yes.
x? 6. What is your y? 2. So now I will write it here. 6 minus 2 plus, this is again we need to find out, 6 plus 2 is equal to 3. So now if I write this, d by 4 plus d by 8 is equal to 3. So if I solve that by taking LCM, d would be 3. D would be how much? 8 kilometers. You can find out. Okay. Now next question. All of you make a note of this. Okay, let's do this question. A man can row at a speed of 4.5 kilometers per hour in still water to a certain upstream point and back. That means he's going up and coming down to the starting point in a river which flows at this much. So they gave the speed of the boat and they gave the speed of the stream, correct? That means they gave a man can row at a speed of this much in still water to a certain upstream point. So they gave you speed upstream, correct or wrong? And back to the starting point. No, we need to find out the speed upstream and speed downstream. So VD and VU. So you know a man can row, this is a particular stream. Man can row at a speed of, so the speed of the boat is given 4.5. And he speed of the boat is 4.5. And what is the speed of the stream? 1.5 kilometers per hour. So man can row at a speed of this. So this is the speed of the boat, very clearly given. That means he can row at a speed of this in still water to a certain upstream point. He will go up and he'll come down. And the river is flowing at a speed of this, very clearly given. So speed downstream is what? 4.5 plus 1.5. Speed down upstream is what? 4.5 minus 1.5. This is 6, this is 3. Correct? Now, we have both the things. They are asking to find out the average speed. So average speed formula is given to you in the, given to you now, I have given to you like some time back. So average speed is equal to upstream rate into downstream rate by speed in still water. That means speed of the boat in still water. Upstream rate, that means upstream rate is what? 3. That means x plus y into x minus y divided by x. Okay, so if I bring all this here, x plus y is 6. Sorry, that is like, okay, like you can write it in this way also, upstream rate or downstream rate into upstream rate, anything is all right. Anything is all right. 6 into 3 divided by, what is the still water? 4.5. So you will get 4 kilometers per hour. Answer. How? 6 into 3 into 10 divided by 45. I've just removed the this one. I've removed the decimal point. So once, so we can cancel ones, 15s, 5s, 3s, sorry, 2s, 4 kilometers per hour. Okay. All of you make a note of this. So I'm giving you two sums homework. You try those sums. Okay, I'll give you one sum homework. One I'll explain you. Fine, you can try both the sums as homework. Don't worry. Evening, however, I'm going to take a class. I will explain you those questions. If you are not getting. So try these questions I'm giving you. If you are not getting, evening I'll explain both the questions to you. Okay, so please do these questions, these two questions homework, and I am saying you, if you are not getting, need not worry. I will explain both the questions in the evening class. Evening, my plan is to take reasoning concept, syllogism. So we will take reasoning in the evening. Okay. Chalo. So in the evening, I'll inform you the timings. Either 6:30 or 7. I will inform the timings to you. Okay. Yeah. Thank you.
Thank you, sir.
Thank you, sir.
Yeah. Yeah.